In this video, we're going to talk about annuities and how to find the value of an annuity. So we use the term annuity whenever we have a situation with equal payments made at equal time periods. So unlike the compound interest problems where we were just putting a lump sum of money into the savings account and then not putting any more money in after that, with annuities we're assuming that we're putting in a consistent amount every month or every year. And some examples of situations where annuity formulas are used include loans, IRAs, retirement accounts, mortgages, which are a type of loan, where you're paying back the loan or the mortgage at equal amounts at equal times. So like once a month you would make your payment. And any time where you have a savings account where you're making equal deposits at regular intervals. So something like maybe a college savings account for kids where you're depositing the same amount on a regular basis. Or like IRAs where you have the same amount taken out of your paycheck every paycheck. So the formula for the value of an annuity, we have some variables that we've already seen. Our P in this case, instead of just being the amount that's deposited once, is going to be the deposit made at the end of each compounding period. So usually it'll be something like yearly or monthly. It could be quarterly as well. But we're making a regular deposit here. We have R, which is the interest rate. And we need to convert to a decimal, like we did before. We have N, which is number of times compounded per year. We have T, which is time in years. And A is the amount in the account after T years. And the formula is A equals P, and then you'll see in the book there's a bracket, 1 plus R over N to the NT, and then minus 1, and that's all over R over N. So what I would recommend doing is typing this into your calculator all at once. Where there's the square bracket, you would need to use a set of parentheses there. So you would type in the number for P and then hit the parentheses button twice. You also need to put parentheses around the NT and parentheses around the R over N in the denominator in order for your calculator to get the right answer there. So we're going to look at example 7. It says at age 25, to save for retirement, you decide to deposit $200 at the end of each month into an IRA that pays 7.5% compounded monthly. How much will you have in the IRA when you retire at age 65? So I need to identify my variables here. I'm depositing $200 every month, so that's P. My interest rate, 7.5%. So 7.5, move the decimal point 2 places. I have N compounded monthly, means that N is 12. And the amount of time that it's in the account, if I'm retiring at age 65 and I started it when I was 25, that means T is 40 years. So now I'm going to plug in A equals 200, 1 plus R over N to the NT minus 1 all over R over N. And again, make sure you're using parentheses here when you type this into your calculator. I'm going to round to the nearest dollar since that's what it asks for on the homework. What you should get here is $604,764. So type this into your calculator and make sure that you can type it in correctly. So that's how much I will have in the account when I retire after 40 years. Part B says to find the interest. Now, part of the $604,000 is interest, and part of it is the money that I was putting in, that $200 every month that I was putting in for 40 years. So to calculate what of that is interest, what I'm going to do is first calculate how much I put in. So the total amount that I put in myself was $200 a month times 12 months in a year times 40 years. And if I multiply those out, that's $96,000. So of that $604,000, only $96,000 was money that I put in myself. All of the rest of it is interest that was earned. And since some of that money was in there for 40 years, it was able to earn a lot of interest over that time because that's a long time period. So to calculate the interest, I would subtract the $96,000 from the total amount in the account. So $604,764 minus $96,000 gives me a total of $508,764 earned in interest. So a pretty high percentage of the amount in the account is actually interest earned. And the reason for that is because it was in the account for such a long time. So one of the things that they always say about saving for retirement is that you should start early when you're in your 20s, and that's because that gives the amount that's put in there early a long time to grow a lot of interest. So next you should look at checkpoint problem number 7. Do this in your notes, check your answer, and then move on to the homework.